In Lesson 19, we'll be reviewing powers, exponents, and roots. Now, Part A is about exponents, and we've already had to work with exponents some, especially when we're working with area conversions and calculating area. For example, we've learned that in area we're multiplying a length times a length, like centimeters times centimeters. And we know that that is the same thing as saying centimeters with a little exponent of 2 above the centimeters. If we're working with numbers, like 2's, 2 times 2 is the same thing as 2 with a little 2 as an exponent at the top right of that larger 2. And all exponents are, it's just a definition in math. We've decided that 2 times 2 is the same thing as 2 to the power of 2. We use that little exponent to represent multiplication of the same number more than one time. So that means that 2 to the third is the same thing as 2 times 2 times 2. 2 to the n is the same thing as 2 times 2 times 2 dot dot dot, where we would have n number of times. That's a variable. We could be talking about 5, 10, 15 times. And so when we're working with exponents, we call the big number, or the number that's the factor, we call that the base, and then the exponent is the small number above the base. And just think about it. This is just a definition. We could have said that 2 to the power of 2 meant 2 plus 2, or 2 minus 2, or 2 divided by 2. But somewhere along the way somebody defined that, and it's just universally accepted as that means 2 times 2. 2 squared means 2 times 2. 2 to the third power means 2 times 2 times 2, and so on. Now we can apply what we know about exponents to working with negative numbers as well. And let's just do some practice problems. For example, let's do negative 2 to the third. And we could call that negative 2 cubed, or we could call that negative 2 to the third power. That's usually how we talk about exponents, is to a power. So just like 2 to the third power, that's 2 times 2 times 2. Negative 2 to the third power, that's going to be equal to negative 2 times negative 2 times negative 2. Now I didn't have to put those dots in between, but I did that just to show multiplication a little more clearly here. So what we need to do on a problem like that is recognize how many negative signs we have. We have an odd number of them. We have 3. So that means our answer will be negative. And so then we just do 2 times 2 times 2 is 8. And so we have negative 8 for an answer. Let's do another problem, negative 2 to the fourth power. So in this case, that means we're multiplying negative 2 4 times. And so now we notice that we have an even number of negative numbers, so we know our answer will be positive, and so that would equal a positive 16. Now look at practice problem C and compare it to practice problem B. That answer is not going to be positive 16 as well. There's a huge difference between those two problems. Hopefully you can recognize it. And it's the fact that in practice problem B, we're talking about multiplying negative 2 4 times. That's why the negative 2 is in parentheses. In practice problem C, we're saying that 2 to the fourth is going to be a negative result. So what you should do on problems like this where you have that negative and it's outside of parentheses is just cover it up with your finger, perform that operation 2 to the fourth, that equals 16, and then uncover the negative sign with your finger, and that'll remind you to put it back on. So that answer is negative 16. Once you try to do practice problem D and E, figure out what those are, simplify them to just a one number answer there. So in D, you have negative 3 squared. So you just cover up the negative sign because it's not inside parentheses. Cover it up with your finger, do 3 squared, which is 9, and then uncover and you get negative 9. That one will have a negative answer. The bottom one will just be negative times negative, so that's positive 9. Negative 3 times negative 3 would be positive 9. In 19C, that's about roots, and it still kind of has to do with exponents. For example, if we had 4 times 4, we know that that equals 16. And then the square root of 16, that gets us back to just the factor of 4. That symbol, it's called the radical sign, and we use that to represent the square root. And just think about area. We call units of area square meters, square centimeters, and that's equal to like a centimeter with a little exponent of 2 that represents centimeters squared. So that word square, a lot of times in mathematics, it means we're multiplying the same factor twice. And we could put a little 2 inside this little notch in the radical sign to help us remember that that's the square root, but usually that's the base root, or the most often used one is the square root, and so we don't consider the 2. We don't usually put it in there because we know by default that that means the square root. Now the way we work with roots, like say we had the square root of 49, we always say to ourselves, what factor multiplied by itself would equal 49? And so we think, what times what equals 49? 7 times 7 equals 49. So the square root of 49 is equal to 7. In a similar manner, the square root of 16 equals 4, because there's a factor. We're trying to find this factor that if we multiplied it by itself would equal 16. That's what a square root is. Now we can have cube roots, we can have fourth roots, and so on. For example, there's a fourth root of 16, and for roots that are higher than 2, we put that number inside the little notch there. So like the fourth root of 16, we just think, what times what times what times what? What factor multiplied by itself 4 times would equal 16? And that would be 2, right? Because 2 times 2 times 2 times 2 equals 16. So the fourth root of 16 is 2. Now it's interesting to note that negative 2, that would also be a fourth root of 16, because negative 2 times negative 2 times negative 2 times negative 2, that also equals a positive 16. So we could have 2 answers there, 2 and negative 2. And the same way we could have 4 and negative 4 over here, 7 and negative 7 here. For right now, though, we will just be concerned with the positive root for these types of problems. However, if we had a problem like this, there's only one answer we could do for that one. What is the cube root? Let me put a 3 in there so you know that I'm talking about the cube root, or the third root for that. And so we're saying, what is the cube root of negative 27? What times what times what would equal negative 27? Well, negative 3 times negative 3 times negative 3 would equal negative 27. So the cube root there is a negative answer. There isn't a positive one that would work for that, because there's no positive factor that we could multiply 3 times and get a negative result for. Let's do a couple of practice problems dealing with roots. Simplify those 2 expressions there. In E, you have the cube root of negative 64. So you have to think to yourself, what 3 factors that are all equal multiplied together would give me a negative 64? Well, there must be some kind of negative number, because you have to multiply a negative number an odd number of times to get a negative result. And so it's negative 4 times negative 4, that would be positive 16, times another negative 4, that would give us negative 64. So the cube root of negative 64, therefore, is negative 4. In F, we have minus the fourth root of 16. So on this problem, what we'll want to do is ignore the negative sign for right now and just figure out what the fourth root of 16 is. Well, we did that earlier. We know the fourth root of 16 is 2. So we just write 2 down and then put the negative sign back in front. And so that would be negative 2. So basically what we did there is we simplified that expression first, that 4th root of 16, and we knew that it was multiplied by -1. That's what that negative means out front, is like negative times that, or -1. You could consider it like a -1 times the 4th root of 16 is just equal to -2. And in part D, that's on evaluation of powers, and in this section we'll just be doing some evaluation type of problems, except these will have exponents in them. So let's just go ahead and do some. Look at practice problem G. You have a cubed times b squared there, and I want you to evaluate that when a is equal to +3 and b is equal to -1. So just like we always do on these evaluate problems, let's go ahead and substitute the numbers in first, and we'll do that right beneath the expression. So we'll have 3 cubed, and then b is -1, so put that in parentheses just like we always put those negative numbers in parentheses, -1 squared. Okay? Let's evaluate each individual power first. So we have 3 cubed, that would be 27, and then that's going to be times -1 squared, which would just be +1. And so we have 27 times 1, or 27. Let's do another one. Let's evaluate that expression when a is -1, x is -2, and y is equal to +3. So we have a -3 times a squared, so that's -1 squared, plus the x, which is -2, and then times y squared, so that'll be times 3 squared. Okay, so let's continue to simplify this. Let's simplify the exponents first. So we have -3 times a +1, and then plus a -2 times 9. And then we'll have -3, and then -2 times 9, that would be -18. And so that equals -21. So when you have a problem that has powers in it, in these evaluation type problems, go ahead and simplify that power first, and then go ahead and do your multiplication and addition as you need to. Okay, well that's all for lesson 19.